Alright, next step was to remove the slip ring. There was a slip ring here, so I removed that. And I also cut the wire. And you must be thinking, oh no, what have you done? You cut the wire. You know, actually, wiring is one of the things that I do so much that I am not afraid of rewiring the whole thing. And it was getting on the way. Now I'm going to push this guy out. But for that, be aware that you really want to be careful with what kind of support structure is used. So what I'm going to do, obviously I'm going to push from this side. Don't push from this side because it's going nowhere. But I'm gonna create a sleeve on the lathe that is gonna go through here, and it's gonna basically sit on this guy here. That way, when I put it on the press and I push this guy down, it will just fall, and it will ensure that nothing on the stator gets messed up. Because if I just put this guy on the press like this and I push in here, I am most likely gonna mess my wiring, and definitely don't want to do that. I think the most rigid portion would be here, and even then it could probably get bent, but I'm hoping it won't, so we'll see how that goes. So I made this leaf. It is 20 millimeters in diameter, and you know, I just picked up a piece of junk aluminum that I had laying around. That's why having junk around is so important, because one of those days it can become the part that you need. And I don't want to go to the metal store and pay 30 bucks for a piece of metal just to do this quick thing here. So this is also a piece of junk. Obviously it's not junk to me. It's basically a plate that I got from some surplus material. And boy, I use it all the time for a whole bunch of different things. In this case, I'm taking advantage of this hole in here. It just happens to be exactly what I need. So whenever I bring junk to my house from the surplus place, I just basically tell my wife, I'm not buying junk, I'm buying tools. Imagine if I had to build this just because I needed that kind of support. Screw that. Now we're taking this puppy out. Let's see if this works. A little bit of pressure here. That's not. Whoops. Okay. I suppose that's how it is. Boy, that was truly there. Now, something that I have to worry about before I just keep on going and probably damage something is that, man, there is a keyway there, so that is probably gonna try to go into the aluminum part. Already stuck. I wonder if it is pushing into it. That would not be good. Let me look at this outside and see what the heck, what kind of a stupid thing I'm doing here. Well, I had to drive the guy back because, just like I suspected, I don't know if you can see it, but the keyway was going in. Now it's very possible that the keyway is a prisoner, so it's not like I can take it out. Oh well. It almost looks like this guy got bent a little bit. That worries me. I don't want to mess up. I mean, if he gets messed up, he gets messed up, but I don't know. I don't know what to tell you right now. But I'm gonna have to make a keyway here, or at least a slot, so that the keyway can go through it without impacting the material. Alright, so the question is, how do we create a groove like the one that you see in there? Hopefully you can see it. How do we create that groove so that the keyway, that keyway there, can go through the inner bore? Well, for that we use something called a broach. And a broach is a cutter in this fashion. It's basically like a shaper kind of deal. Although the shaper, I believe, uses just one bit. This is more like it's called a broach. That's what it's called. And then what we do is that we use shims to continuously increase the pull in this direction. And this guy gets longer, or I should say deeper. I don't know if you can notice that this tooth, so there are no tooth in here, but then the tooth get progressively longer in this direction, right? So you're going to be removing material, and then the trick becomes how do you push this guy on this way. And you can use a press or pretty much any other method that you can think of. So I started doing this, but obviously this is not gonna work, and the reason is that the diameter, or I should say the width of the keyway that I'm doing here, okay, this width is less than the one on the keyway that is in there. As you can see, this is clearly wider than this. According to the broach, this is 1/8 of an inch in width. So I think I need somewhere like 3/8, but I don't have a 3/8. And for me to start making parts, like trying to get a broach or trying to find a way just to tackle this dinky little detail, man, that seems like a lot of work. So what I'm gonna do is I'm gonna put this on the mill, and I'm just going to cut a little canal here, like a pocket, but obviously it's gonna go all the way, you'll see. And the reason is because, you know, I think it will be okay if there is no full diameter applying a force. I think it will be okay. Well guys, here's the groove. There was no intention of making this perfect. As you can see, there are some blemishes here and there, but you know, I just did this by hand with the pendant, so there was like I said, no need to make this beyond pretty. And now we can press. And voila, it has come out. The stator is in perfect shape, so I can definitely reuse it. And here's the shaft. It has a keyway. It has I don't know what you call that. It's like a knurling kind of deal to increase the diameter of this guy so that it can be pressure fitted. All of these will have to be redone, but my goal is to have the shaft being basically this twice, so it's gonna come on the other side of the motor. That means that I also have to rework the other side of the wheel. Alright, so let me show you what I've done here. I was able to mount the wheel on the three-yaw shock. Be aware, however, you want to be extremely careful because it is of crucial importance that you don't crush the magnets. If you crush the magnets, you can pretty much kiss this goodbye. So luckily, and I'll show you after I remove it from here, but luckily there is enough headroom to mount it in such a way that the jaws are pushing out into the wall of the wheel. It is not super stable, so I didn't do this very fast. This has to be super light cuts and slow speed, and of course it's not going to be perfectly centered. All I care is that the shaft goes through, and that is already happening. So like I said, basically I use a drill to do a pilot hole and then the bottom bar to enhance this, increase that. And the surface that I used. Now, when you're removing the wheel from the chuck, be aware that now you have to close the chuck, not open it, because we're using the opposing surface. I was using this surface, and I'm basically using this side. There is a lot of crap, so I'm gonna have to clean this up. Luckily, this is all aluminum, which is not magnetic, so this should clean easily with air. If this was iron, we would be hosed. But if this was iron or steel, this would not work because the magnets have to be enclosed in a non-ferromagnetic surface. Otherwise, the magnetic field, man, it will be havoc if this was magnetic. So that's it. Now to clean this up, and man, I'm almost done. Now, all I have to do now is the shaft, but I'm thinking this video is already long enough, so that may be another video. Well, YouTubers, I'm gonna have to finish this up on another video. As it turns out, the shaft is not gonna work well with my lathe as it is today. Unfortunately, you know, I just placed the lathe when I moved into the house, and I just let it there. I never took the time to remove the twist and align it, level it, all that stuff. So unfortunately, I'm getting a bunch of inaccuracies on the outputs, which may be okay for some things, but not for a shaft. So I'm gonna have to work on the lathe before I can work on the shaft. But at least we were able to learn, you know, how to open up the motor, how to remove the different components, and I think that was worth it. So I'm hopeful that you were able to learn a few things with this video. I do want to thank you for tuning into my YouTube channel, and I'm gonna see you on the next one.